In this video, I will show you how to create your first serverless API by combining an Amazon API Gateway and a Lambda function. API Gateways enables us to create APIs and to expose our backend services to the world. In our case, the backend services are Lambda functions, but it can just as well be applications running on EC2 instances or any publicly accessible web service. Today, we are going to create a publicly accessible endpoint exposed by an API gateway and connected to a Lambda function. This way, we can perform an HTTP request to that endpoint, and this request will then hit a Lambda function, which will then execute. So, now we know what to make, but why? We need a use case. Well, I think I have an idea. Take the example from the previous video, where we got a Lambda function to store a list of birds into a database. What if we just want to register a single bird? Then maybe it seems a bit unnecessary to upload a whole file. So maybe we want to create an HTTP endpoint where you can just do a post request with a body containing the data of a single bird. So let's do that. For this, we need a few resources. We need a DynamoDB table, a Lambda function, an IAM role with some DynamoDB policies, of course, and lastly, we need an API gateway. Let's start with DynamoDB. I'm yet again going to reuse the awesome birds table, which I created in one of the previous videos. Now we need a Lambda function with access to our DynamoDB table. If we go over to Lambda, you can see that I have already created a Lambda function called createBird with the correct IAM access. So when we use Lambda functions together with API gateways, we need to know what kind of information can we expect to retrieve from the gateway. When performing an HTTP POST request to our API gateway, it sends the request body as part of the event object which get passed to the Lambda function. In other words, we just need to extract the request body from the event object like this. And we should also parse the event body as a Python dictionary. Using the Boto3 SDK again, we can write the code for putting the bird into our DynamoDB table. And at the bottom, let's just create a response object telling the user that the bird is safely stored in the database. And next, we can create our API gateway. Go over to API Gateway. For this demo, I will create an API of type HTTP API. I would also recommend checking out the other options when you create your API. REST API could, for example, also be a good alternative, since it can give you a bit more control over your API and provide some more options when it comes to configuration. For now, let's choose HTTP API. Now we get to choose which integrations to add to our API. So let's do that. Since we are going to use Lambda, then we of course need to choose that. Next, choose our Lambda function. Perfect. But what should we call our bird API? Well, why not just exactly that? Birds API. Now that's decided, we can go on to the next step, which is to configure the route or path to our Lambda function. I'll just write birds. We also need to decide on what type of HTTP method this endpoint should accept. This should of course be POST, since we want to create or store a new bird. Now hit next. We're almost there now. We just need to decide about stages. If you don't know what stage is in the context of an API gateway, it just means that you can have multiple stages which functions as different environments of the same API that you can deploy separately. This way, you can deploy changes in one environment at a time, and possibly discover errors in your API config before updating your production environment or stage. But for now, we only need one stage, and that's the default stage. And we want to have auto deploy enabled. Hit next, and then create. Beautiful! Now we have created an API gateway and connected it to a Lambda function. Now would probably be a good time to test our API. But wait, we need an URL where we can reach our API. Fortunately, AWS is so kind as generating a random URL for our API gateway, right here. So I'll just use that one. To perform the HTTP request, I will make use of an application called Postman. You can of course just use the terminal, but for demo purposes I think it's a good idea to use Postman. Let's create a new HTTP post request. Paste in the URL from the API gateway, as well as the path, which was /birds. Now we need to create our request body. This should be a JSON-structured request body containing all the necessary fields to create a bird object. Lastly, hit send. Well, we got the response code of 200 and the message we wrote, which means that everything went as we intended. Something to keep in mind is that this API is completely open and exposed, so anyone with the URL can access your API. So I would recommend not sharing the URL until you have some form of authentication in place. And if you're very nervous, you can of course just delete the API when you are done with this demo. We have now created our first API using an API gateway, a Lambda function, and a DynamoDB table. Previously, we created an endpoint where we could perform an HTTP post request to store information about a bird. What if someone else posted a bird to the database, and you want to retrieve that information? Well, then we can create a new endpoint in our API, where you can perform an HTTP GET request to retrieve that information. Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel. And to get notified when I publish more content, please smash that bell icon. So, what do we need to make this API endpoint? Well, we need an API gateway, of course, a Lambda function, a DynamoDB table, and an IAM role. Surprise, surprise! I'm going to reuse the awesome birds table, and I have already created a new Lambda function with the correct IAM access to our DynamoDB table. So let's start by writing the necessary code to query our DynamoDB table for that bird information. First, we need to initiate a table object so that we can communicate with our DynamoDB table. Now we can query the database to find a bird object identified with an ID like this. Response equals table.getItem and then provide the parameter key, which is a JSON object with the field name ID. And then we need to provide the value of our ID. So, where do we get the ID from? Well, you probably guessed it. It should of course be accessible through the event object. But under what key inside the event object? I'm planning on providing the ID as a path parameter in my HTTP GET request. So then we should be able to find the ID under event, path parameters, and ID. You may wonder why I had to ask specifically for the ID inside the path parameters object. Well, in the API gateway, we can define endpoints with multiple path parameters, And there we also have to give the path parameters names that get passed onwards to our Lambda function inside the event object. This way, we don't need to manually extract the path parameters from the URL. More on this later when we create the API endpoint. Lastly, we should create our return object and send the bird information in the response body. Now we can deploy our Lambda function and go over to the API gateway. I have here the API gateway we created in the previous video. To create a new endpoint, we can just navigate to Routes, click Create. Now we choose a HTTP method. This should be of type GET, and the path should be /birds and then /curly braces ID. By writing curly braces with ID inside, we define a new path parameter called ID. And as I mentioned earlier, this gets passed to our Lambda function as a path parameter with the name ID, along with whatever the value a user requests in that part of the URL. Now the route is created, we need to attach an integration with our Lambda function. To do that, just click Attach Integration, and then create and attach an integration, and then choose Lambda and our Lambda function. Lastly, hit Create. The new endpoint should now be accessible and connected to our Lambda function. It's now time to test our API. I'll just use Postman again, but this time you can just as well use your web browser. Just paste in the URL, and then add the path we created, and lastly the ID of the bird in our DynamoDB table. The moment of truth. Yes, it worked. So today we have created a new API endpoint. This is now shaping up to be an actual functioning API. Now you should know some of the basics when it comes to API gateways. We have learned how to make endpoints that can return information using HTTP GET requests and how to post information to our API using HTTP POST requests. These are probably the two most common use cases for an API. In this video, we will discover another use case that probably are a bit more obscure, but can be very useful. I am of course talking about making our API redirect users to another resource. Redirect can be very useful when, for example, we have a website with a link to an external resource, but we want to register every click on that link. Then we can send the user to our API first, register the click, and then redirect him or her to the correct destination. In our case, we just want to send users to Google Images each time a user requests images of a specific bird. So, how is this going to work? Well, I was thinking about adding another endpoint to our API where users can perform an HTTP GET request, and then the response will contain a status code of 302 and a location header with the destination link. A web browser will then automatically go to the website located in the location header. Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel and smash that bell icon to get notified when I publish more content. So let's get started. First, go over to our DynamoDB table. I had to add an image URL attribute to each of the bird objects in our DynamoDB table. This attribute should contain the destination link, which in our case is just a Google Images search for the respective bird. If we go over to Lambda, you can see that I have already created a new Lambda function. I have also added the correct IAM access to our DynamoDB table. To get the image URL, we first need to know what bird the user requests. And you probably guessed it, we can just reuse almost all the code from the previous video, where we retrieved information about a bird given the bird ID. I'll link that video above in case you missed it. Now, all we need to change is the return object. Instead of returning status code 200, we want to return 302, which is redirect, and we don't want to return any response body, just an HTTP header called location, with the value set to the image URL from the bird object. Lastly, hit deploy. Now that's done, we can create a new endpoint. Go over to our API gateway, then add a new route. This should, as I said earlier, be an endpoint of type GET. And the path can be /birds, /curly braces ID, /images. So now we can just attach the integration with our Lambda function. And we should be good to go. I'll just copy the gateway URL, open a new browser window, paste in the URL, and add the path and the path parameter, which is the ID of our beloved penguin, which I can just copy from our DynamoDB table. And at the end, add the new image URL path, and lastly, hit enter. Look at all the cute penguins. Well, what can I say? That wasn't too hard. Now we can see as many pictures of penguins as we want. So what's next? Well, up until now we have made use of HTTP API gateways. In the next few videos, I'm going to show you how to make use of some of the more advanced features available in REST API gateways. These features are, for example, request body validation and authentication using AWS Cognito. Up until now, we have made use of HTTP API gateways. It has proven to be very useful and easy to configure, but it has some limitations. At the time of creating this video, it's not possible to validate the request body before hitting our Lambda backend. But this is a feature that is available in REST API gateways. So, in this video, we will create a new REST API gateway and an endpoint connected to the createBird Lambda function. This way, we can validate if all the required fields for creating a new bird is present in the request body before hitting the Lambda function. When working with document databases like DynamoDB, it can be very useful to have some form of validation, since the database accepts almost all kinds of data structures and fields. You can, of course, perform the validation in the Lambda function code, but why not make use of the built-in validation in the API gateway? Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel and smash that bell icon to get notified when I publish more content. Now, let's start by going over to API Gateway, create a new REST API Gateway, give the API a name, and click Create API. Now we want to create a new endpoint. To do so, create a new child resource in our API, give it a name of birds, and a path, which is /birds. Also enable CORS. By selecting CORS, an options method is created for us with basic CORS configuration, allowing all origins. Inside this child resource, create a new method. This should of course be of type post, and then choose Lambda as integration type – and select the createBird Lambda function. Now we get a warning that the API gateway gets access to invoke our Lambda function. Just hit OK. So, what about that request validation? Well, now we have to create a new model. Go over to Models, hit Create, give the schema a name as well as content type, which is application/JSON. This model should be a JSON schema where you provide a JSON object with a set of properties. I'll provide a link in the description below if you want to read more about JSON schemas and how they work. I'll just paste in a JSON schema I have created for a bird object. The properties in my JSON schema is ID, name, can fly, which is a boolean, colors, which is an array of strings, and image URL. I've also defined a set of properties that is required to be present in a request body. These are ID and name. So now we can hit Create Model. If we go back to Resources and open the Post method and Method Requests, here we can choose Validate Body under Request Validation. And under Request Body, type in application JSON and choose the model we just created. Now we can deploy our API. Just go over to Actions and hit Deploy API. Since this is the first time we deploy our API, we have to create a new stage. If you remember from the previous video where we created the HTTP API Gateway, we could just use a default stage. But that does not exist in REST API gateways. So I'll just create a new stage called Test and hit Deploy. Now that our API is deployed, we can finally test it. Just copy the gateway URL and go over to Postman or your terminal, paste in the URL and add the path, which is /birds, and create a request body as I have done here, and hit Send. Awesome, the bird is stored in our database. If we go over to the DynamoDB table, you can see that the bird is there. So, what would happen if we were to do a post request without some of the required fields? Well, then we would get a 400 bad request in response. And the request would not hit the Lambda function. It can always be smart to have some form of authentication to protect our APIs, especially endpoints where users can perform changes to the underlying data. In our case, am I talking about the post endpoint created in the previous video? So today we are going to add authentication to that endpoint. Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel and smash that bell icon to get notified when I publish more content. Let's get started. First, we need to create a new Cognito user pool. If you haven't used Amazon Cognito before, it lets you add user sign-up, sign-in, and access control to your applications. In other words, you don't need to write complicated authentication and authorization code in your applications. Instead, let Cognito handle that for you. Now, click Manage User Pool, then create a new user pool, give the pool a name, I'll call mine My Birds, and click Review Defaults. Now just scroll down and hit Create Pool. Now we have created a user pool. You may wonder what a user pool is. Well, the short version is that a user pool is where you store users. Inside a user pool, you can also configure how users can authenticate themselves and control their access to different applications. I'll provide a link in the description if you want to read more about it. Next, we need to configure a domain users can access to authenticate themselves. I'll just use an Amazon Cognito domain and call it something like birdtest1. Since this domain has to be globally unique, I first have to check availability before saving the changes. Now that's done, we also have to add a resource server with some scopes to control what access we may get, given that we are authenticated with our user pool. I'll call the resource server birds, and the identifier can in this example be the API gateway name. Now just create one scope called bird.create and save the changes. So what now? Well, there is still some configuration to be done. We can now create a new app client. App clients allow us to perform unauthenticated API operations like sign in and handle forgotten passwords. I'll provide a link in the description if you want to read more about app clients. So give the app client a name and hit create. Next, we can head over to app client settings. Here we want to do some changes. First, enable Cognito user pool under identity providers, then update the callback URL. I'll just set it to localhost for the sake of this demo. Under OAuth 2, enable implicit grant as OAuth flow. And enable phone, email, and OpenID under OAuth scopes, as well as the custom scope we just created. It's worth mentioning that I'm using implicit grant just for demo purposes, so you should either use authorization code grant or client credentials for your production application. Lastly, hit Save Changes. Now we need a user in our user pool. So let's head over to Users and Groups and create a new user with some temporary credentials. Well, that was a handful. Now to the easy part, adding authentication to the API Gateway. Open the API Gateway, go to Authorizers and click Create New Authorizer. Give it a name like BirdAuth and choose Cognito as type. Then choose the Cognito user pool and under token source write authorization. The token source is the HTTP header where you send the bearer token after you have been authenticated. Now the authorizer is added to our API, we need to attach it to our post endpoint. Go to Resources and open the post resource and the method execution. Here we can choose our new authorizer under authorization. And now add our custom OAuth scope, which we can find under App Client settings. Lastly, deploy the changes. Now go back to the Cognito user pool. From here, launch the hosted UI. If we take a look at the URL, you can see that this corresponds to the domain we created previously. And Cognito is so kind as hosting a web UI where we can log in using our username and password. And we will get a token in return. Since this is the first time we log in, we have to create a new password. Okay, now that we have set a new password, we can go over to Postman and test the API endpoint. I have here the request from the previous video. I have inserted the URL and a request body. But now we also need to be authenticated. So go over to the Authorization tab and choose OAuth 2. We want to configure a new token. So give the token a name, grant type should be implicit, and the callback should be localhost. We want to copy the auth URL from our user pool hosted UI, as well as the client ID. Now hit Get New Access Token. Let's just type in the username and password. And success! We got a new access token. Since Postman is an awesome tool, it adds the authorization header to our request and pastes in the token we got from Cognito. Now all that's left is just to hit send. And yay, it worked! Now you have learned how to create your own Cognito user pool and how to implement that into your API gateway. As I said earlier, this is probably the last video about this topic for a while. I'm going to focus more on infrastructure as code, but still related to APIs and Lambda. I'm going to use the serverless framework and probably later some Terraform. If that sounds interesting, please remember to subscribe to my channel, and if you want me to cover more Lambda and other AWS stuff, just leave a comment and maybe I'll create some more videos about that in this playlist. But for now, see you in the next topic.